SQL servers on EC2. So let's come back over here. Now, we just finished talking about different independent SQL Server instances that have their own storage. Like with an availability group here, I've got two different pizza boxes. Maybe one's Dell, maybe one's HP. Maybe these are both VMs, but each of them have their own copy of the data files and log files. Well, there's another way that you can do SQL Server, which is to use shared storage. Shared storage from Pure, Dell, EMC, Equalogic, whoever it is that you want to buy your shared storage from. But shared storage is usually managed by SAN administrators, a different group of people. Now, if I just have one instance of SQL Server and its data lives out on the SAN, this is not high availability. This is not disaster recovery. This is just another single point of success. I like these. They're nice. They're expensive. I like expensive things because expensive things make me look inexpensive. So I'm all about that. But this isn't high availability and disaster recovery until you add something. And the thing that you usually start by adding is a failover clustered instance, or an FCI. This is what your grandmother used to call an active-passive cluster. When your grandmother was managing SharePoint and she had her own little data center down in the closet to keep track of all her knitting projects, an active-passive cluster was two pieces of hardware. Maybe it was Dell and Cisco, or Lenovo, two pieces of Lenovo gear. Both of those SQL servers over there, GovDBA says, my SAN guy argues with him on this. Bring him in. We can talk through it. So over there on the left, I have these two physical SQL servers. They can be VMs too as well. But one of them is always watching the other. One of them is always watching and just seeing, are transactions still going okay on there? Is everything okay? And it's running periodic health check queries against his brother. SQL Server, the binaries, are installed on both of these. And they're built on top of Windows Server failover clustering, which is watching and doing health checks between the two of these so that if a top guy goes bump in the night, the bottom one can automatically take over and keep going. There's a failover. The failover takes time. On a good day, the failover takes 5 to 30 seconds, but you don't fail over on a good day. You fail over on a bad day, and sometimes things can take 30, 60 seconds, or sometimes the failure can just fail. It doesn't actually work. But it's a pretty doggone reliable technology. It's been out there for a couple of decades. It's undergone changes and evolved over the years. But these days, we don't call this an active-passive cluster anymore, because if you wanted to, you could run multiple instances on here. You can layer in things like AlwaysOn Availability Groups. It can get pretty complex pretty quickly. You do still have a single point of success. What I mean by that is if SQL Server, remember you hit those SQL Server bugs that will knowingly write trash data to disk? This is the disk. So we only have one copy of the data. There's no automatic page repair. There's no recovery from oops deletes. This person here, whoever manages the SAN, can take snapshot backups as often as they want, depending on how the brand of SAN is configured in its backup software. But it is still a single point of success until we start copying that data elsewhere. And the data inside there can even already be corrupt. We can already have problems with it. This thing doesn't know, not this thing, he's okay too, but this thing simply doesn't know that we're having any kinds of problems. Now, this is what your grandmother would have called an active-active cluster. Here we have two separate SQL Server instances. They're all sharing their data on shared storage. Both of these two clusters can be active for different databases at the same time. Maybe the top one is running our accounting databases, Dynamics, whatever. The bottom one might be running SharePoint, our homegrown website. Both of these SQL servers are tapping each other on the shoulder, constantly checking each other. Is everything okay? And then in the event that one goes bump in the night, the other one can take over all of the hosting duties. Performance will get worse. This isn't a very common setup because you're paying licensing for each of these. So if it's 8 cores on the top box, 8 cores, I feel like I'm dancing now. 8 cores on the, woo, thanks Katamuthu, thank you, I appreciate that. Um, so if you buy this, it's 8 cores on the top box, 8 cores on the bottom box. You're paying for a fairly high amount of licensing, and the hardware is actually the cheap part compared to the licensing. Remember, SQL Server Standard Edition is $2,000 US per core. Enterprise Edition is $7,000 US per core. Well, remember, for every box that you query, as long as you're under software assurance, you actually get extra free secondaries. So what you can do is you can set up a free secondary down here that's just a standby instance, already has SQL Server installed, and you can fail instances over to it if you want. This guy doesn't cost you that much because he doesn't keep a copy of the databases. The only copy of the databases are up here, so you don't pay for redundant storage. This, what's here on the screen, is extremely popular in enterprises. When you start talking about dozens of SQL servers, you don't want to maintain dozens of copies of databases. This lets you have just one copy and have high availability. It's not disaster recovery though, because you wouldn't put heads for this, different compute nodes in different data centers, if your only storage was just inside one data center. And as soon as you start replicating data centers, then that's a whole different storage discussion entirely. That is disaster recovery. Disaster recovery is what we think of whenever a data center goes bump in the night, the shared storage goes bump in the night. So let's reset back to just one individual SQL server in one data center, and then let's start layering in disaster recovery. If I want to cross the line between primary data center and disaster recovery site, the single most common solution out there is log shipping. What log shipping means is up top on the primary, every 5 minutes, 15 minutes, whatever, every so many minutes, the primary is taking a log backup over to a file share. Side note, never, ever, ever, ever write your backups to the same place where your data and log files live. Never write your backups to the same place where your data and log files live. You want insurance. If all your eggs are in one basket, you will lose that basket. It is only a matter of time. It's not if, it's when. You will lose that basket, full stop. So my favorite way to do this is just whenever I take over SQL servers, I'm going to start writing my backups to a network share instead of writing them locally. Not the DBA you're looking for says, made that mistake once, not making it again. Yancey, thanks. Glad you like my transitions. So just as a side note there, really important career-wise, always write your backups to a network share, something that isn't sharing the same storage as your SQL server. So as long as you're regularly writing your backups to somewhere else, well, then what you can configure is you can have another SQL server down here somewhere else that's constantly watching that file share and pulling backups down and over and across as soon as they show up. It'll just simply pull them down every 5 minutes, 10 minutes, whatever, and pull them across to the data center. Dean says it's kind of obvious you don't back up on the same place. See, that's how you really know that it's true. Even the people at YouTube in the comments know you don't do that. Even them. Oh. And the YouTube comments, those people, they never know anything, and they even know that you don't do that. So in here, this isn't really technically a SQL Server feature. Anybody could do this. You could just write a script to pull the databases down and restore them over here. All you're really doing is pre-staging your restores so that they're already done ahead of time. Technically, it's a SQL Server feature, and in the sense that there's a GUI for it over in SQL Server Management Studio, but I know people who write scripts for this by hand rather than relying on SQL Server. Now, drawbacks with this is it won't be kept up to date in real time. The other methods that we've talked about so far, every insert, update, and delete that we do up on the primary, it's been automatically replicated nearly instantly or instantly down to the bottom side, but there's a lag time here. Because the top isn't doing backups continuously, it's only doing them every 1 minute, 5 minutes, whatever. So there's a lag time. You may lose 5 minutes of data for your backups to happen. Then another 5 minutes, say, just to pick a number, to restore the databases down on the bottom side. So you'll lose 5, 10, 15, 20 minutes of data, all based on how frequently you back up your log files. But you know what? This is disaster recovery. And usually companies are okay with that. Because disaster recovery is more about a gamble. How often do we think we really need to have that happen? Shrech, I'm not going to cover that just because we're talking about high availability and disaster recovery. Another method that you could use for disaster recovery is database mirroring. Now, we talked about database mirroring earlier, but I was talking about synchronous mirroring. Every time we did an insert, update, and delete on the primary, it was instantly replicated down to the secondary. Asynchronous mirroring is a little different. Just tell SQL Server, hey, when you get time, when you're not busy, can you replicate commands down to the disaster recovery site? There's no limit on how far behind it can get. And to tell you how far behind it can get, I'll tell you a little story. So once upon a time, I was a database administrator, and I had jobs set up to do things on the weekend, like you probably do, like backups, CheckDB, index maintenance, ETL, things like that. I had those jobs set up to run things like daily and weekly. One weekend, we needed to do a disaster recovery test. The company that I worked for was going to fail over everything from one data center over to another. And I knew that was coming. All of us knew it was coming because we came into a conference room. You remember the old days when we could get together in person. We would get together into a conference room, and we were all ready to go, and we were all doing the failover at exactly the same time. So it was kind of like those old NASA movies where they would go around the room in the control room and they'd say, launch control, go, ballistics, go. I don't think NASA has ballistics. But they would go around the table and everyone would say go or no go in terms of their licensing. Underground pianist, no. So, and specifically Azure SQL DB. There are other flavors where that can be true. Drop Table says, is this a new side camera? Yes, brand new one. Just my wife's, I'll tell you that story in a second. So they're going around this table. SharePoint, go. Accounting, go. And I'm getting ready. The table's coming around to me, and I know they're going to yell out SQL Server at some point, and I'm looking at the database mirroring monitor, and I had asynchronous database mirroring, and I had a job set up to rebuild my indexes, and I'd forgotten to disable that job, and my mirrors were 4, 5, 6 hours behind because I had really fast primaries principals. They could write a whole bunch of transaction log activity very quickly, and then they would gradually push data across the network to our disaster recovery data center somewhere over there. They would gradually push changes across to the DR data center, and what I hadn't counted on was that everyone was using that network wire today to sync everything else that they were doing. So I was way behind. And I knew that when it came around to me, I was going to have to say, sorry, no go. I'm going to lose 6 hours worth of data if we fail over. Lesson being, I got to make sure that my management understands asynchronous means just flat out asynchronous. I could lose a relatively unlimited amount of data. The story had a happy ending. As it turned out, we were going around the table and people were like, go, go. And they got around to Oracle, and the Oracle guy goes, I'm sorry, no go. I'm not able to do it. We were supposed to be taking striped backups. It was supposed to be working in both locations. We forgot to configure that. If we fail over, we won't have any backups. I was like, whew, thank God. And at the same time, I was like, get up with mock outrage. Dave, how could you? We've been planning this for weeks. And I'm like, ha, 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 ha. It's actually not my fault. Drop Table employee said, is that a new side camera? So it was really funny how that worked. My wife happened to watch one of the streams that I did, and she saw me cut over the side camera, and she's like, that doesn't look very good. And I said, yeah, honey. I said, that's why I wanted to get a new side camera. I know they're really expensive, and I've already bought a couple of nice cameras in here. And she's like, oh, that's okay. You have my permission. You can go ahead and get a new side camera. And I was like, oh, yeah, it's fantastic. So Underground Pianist, I'm going to touch on yours just a little bit more. So you said, can you log ship to Azure SQL DB? Azure SQL DB doesn't allow log shipping restores, doesn't allow transaction log restores. So it's just not a failover kind of option to Azure SQL DB. I have faith that at some point they'll allow it for maybe something like managed instances, but it's still a long way off there. Vimal asked over on YouTube, asked another good related question. If we have a 2-node availability group, do we have to have both of the nodes on the same configuration? No. You can have one be a physical box, one be a VM. You can have one be an 8-core box, the other be a 16-core box. It does have licensing implications. Your free standbys can't be larger than your primaries, but it's totally okay if the primary is beefier than the secondary. Just as a side note though, if the primary is really big and the DR secondary is really small, you'll have problems when you fail over to DR. So just make sure that that's in writing. Don't assume that people know that workloads are going to be slower in DR. Plus, often when you fail over to DR, people run more queries, not less. Like they're even more freaked out. There's more going on. So I'm always really careful about that situation. I've been burned by that. I have the scars. So with database mirroring, I can go across 2 data centers. It just makes sense if I do it as asynchronous. Then you have to know when you fail over to DR, the DR node may be behind. It may be hours behind. Arkansas Snowman says, is this like Stack Overflow in real life? Well, you can't touch me, so I guess it's not real life. That should be your gauge. If you can touch me, it's going to a very dark place. Speaking of Stack Overflow, this is an infrastructure like Stack Overflow. So here we have an always-on availability group. Looks just like the last slide, but this is where it starts to get cooler. With always-on availability groups, you can choose which nodes are sync, which nodes are async. You can choose how many replicas you want. We had a slide earlier on that talked about it constantly being able to add more replicas as SQL Server drops newer and newer versions. It's up to you how many secondaries you want to add. Just be aware that if you query that secondary, you're going to have to license that secondary. So we've covered both high availability and disaster recovery independently. Now let's go throw them in together. This is what we call like the polo and khakis of the business world. This is the single most commonly implemented infrastructure to get you both the combination of high availability and disaster recovery. Up top, I have a failover cluster, like we discussed earlier. This is what your grandmother would have called an active-passive cluster. We have 2 nodes, each of which are different independent pieces of hardware, like physical or secondary, or could be Dell's, EMC, Cisco, whatever. Underground Pianist, sure, if you go to our site and click training up top, you can buy this course. That includes the PDFs. So then down at the bottom, I'm also doing log shipping. Since every, say, 5 minutes up there, I'm writing my backups up to that file share. Then on the secondary, right here from Gianco, right down here on the secondary, the disaster recovery can automatically pull those backups down and restore them. What I love about this configuration is that the top half is built on top of Windows clustering, but that can fail. And when it does fail, when your cluster goes down for the count, you have a, oh, thank you, Stratec Henry. That's very nice. Thank you very much for subscribing. I appreciate it. So what you can do then is, in case this thing, the cluster ends up blowing chunks, now you have a totally separate SQL Server that is not relying on the cluster at all. This is different than availability groups, because with availability groups, when the cluster goes down, and it will go down, when the cluster goes down, you're boned with availability groups. The whole thing is downtown Julie Brown, by which I mean wildly outdated and no one watches it anymore. I miss Julie Brown. This is really simple in terms of, like, I think a polo shirt and khakis, what the vast majority of businesses rely out on there. Doesn't matter whether you're in physical or virtual, doesn't matter if you want to span cloud providers. This is just a time-tested technology that works really, really well, combination of technologies. But it's not just one technology. It's multiple technologies. It's a failover cluster, plus it's taking log backups, plus it's restoring those log backups somewhere else. So it's harder when you think about it conceptually than availability groups. It's just that availability groups are also a really hard technology on their own. And when the cluster goes down, you have a single point of success that we worry about. And the larger that you become, the larger of a company that you become, the more SQL Server instances that you have, the more common it is to switch over towards an infrastructure like this, where you have an active cluster, or what we now call a multi-instance cluster, a Windows cluster up here up top that has multiple instances stacked up on it. And then we have one or maybe 2 or 3 instances over in DR that are just acting as secondary, continuously restoring those transaction log backups. This gets kind of expensive. It's a little bit harder to maintain because there's a whole lot of moving parts. But this, again, is an extremely common configuration for very large enterprises. All right, so now let's switch over to questions. What questions y'all have around high availability and disaster recovery? I'll let you open the floor to any HA and DR questions that you have before I finish up and go downstairs and go get my